Okay, yeah, welcome back. Now, we'll be looking at this question. This is a source voltage to the buck boost 40 volts, and the switching time is, the period for the switching is 130 microseconds, and the inductance of the inductor is 250 microhenry. And then we have the capacitance of the capacitor, 125 microfarad. And then the output power is 80 watts with output current of 5 amps. Now the question is, from here, you should calculate the duty ratio. Duty cycle, you said VO over Vs is K over 1 minus K. K is VO all over Vs plus VO. Let's see, we don't have VO here, but we have Vs. Let's just get our VO. We have power, okay, we know P is IV, so that V is P over I. All right, P is 80 divided by 5, so we have 16. So our duty cycle, K, right, 16 divided by 40 plus 16, right? 0.286. So now average input current. Since we have the power out here, right, you can have power in. So number 2, P in equals P out. So that we have I in, V in, that is IS, Vs equals IO, VO. Okay, so that I source with IO, that is PO, so we'll have PO divided by VS. Okay, divide by 4, so we'll get that. Oh yeah, let's say if you want another kind of formula, you can also use like that. IS is KIO over 1 minus K. All right, you can still use this if you want. So I input, I source is the same as KIO over 1 minus K. So if you just know the duty cycle, this cycle is 0.286 multiplied by output current of 5 amps divided by 1 minus 0.286. All right. Okay, now the next question is to calculate the peak-to-peak ripple voltage. Delta VC. All right, calculate delta VC, okay, which is a peak-to-peak ripple voltage. Remember that the current going through the IC, delta V, delta T, we know that. So what you do is you just use your normal time. Okay, time of on, all right. If you switch this on, what is going on here will be minus IO, right? When you switch this thing on, current will flow like that. So this will be cut off. Current that flows through here, okay, IC will be minus IO, right, at time of on. So in other words, here, I'm going to put minus IO equal to C. Then here is your delta V that they want us to calculate. Divide by, here is KT, time of on. To get this, delta V becomes minus IO KT divided by C. IO is 5 times 0.286 times T, 130 microseconds, divided by C, and C is 125 microfarad. So micro, we take out this micro, 1.487. So you get 1.487 volts, okay? Minus 1.487 volts. The next question is, so now let's see, I said if we are asked to calculate the peak-to-peak ripple current of the inductor. All right, that is number 4. I'm sure here will be okay. Let's say number 4. Remember we said voltage across the inductor is L delta I over delta T. All right, so they want us to calculate this. So that here we have delta I is the same thing as VL delta T divided by L. All right. Now, this VL equals to VS when this is switched off, on. All right. So we have VS, and this delta T is a time of on, and time of on is KT, and then divide by L. All right. You substitute the values. So what is VS? I have 40 multiplied by 0.286 multiplied by T, 130 microseconds, divided by L, 250 microhenry. So micro, we take out micro, 5.9, 5.95. All right, 5.95 amps. Now, if you are asked to calculate the peak current of the inductor, the peak, remember, look, here is a peak to peak. Here is between this and that. So delta I. But if you want to calculate the peak, all right, we said peak, I peak, hope this is clear here. I peak for the inductor will be I average here, average there, right, plus delta I over 2. And we know what average current is here. Average current, we said, is I in divided by K, right? So we have that to be I in. Let's just put the value there. I in as our IS, which is 2. Now 2 divided by 0.286 plus 0.95 over 2, 9.968. So 9.968. All right, amps. Now the next is the peak transistor current. Remember, the peak transistor current is the same thing as the peak inductor current. Okay? So whatever that you have here is what you got here also. So peak transistor is the same thing as the peak of the inductor current. So that means whatever we have here is also the same thing as that of the transistor. Now, the critical values of L and C. Critical values of L and C. Let's start with L. So I'm looking at number 7. We know that VL, we say VL is the same thing as L delta I delta T. All right, so now the next question is to calculate, the seventh one is to calculate critical value of L and C. Okay, so to calculate critical value of L and C, let's look for that of L first. VL is L di dt. This is I L delta I, okay, dt. Now, and we said that, which is the same thing as saying, we can write now critical value that VL with L critical multiplied by twice, this is 2 times I average. Okay, I average on inductor divided by time of on, so which is KT. All right, remember that at critical value, the ripple current will be twice, okay, of the average value of the current flowing through here. All right, twice of that. And we know what I average is, which is I in over duty cycle. So we say that this one is I in over duty cycle if you watch the previous video. All right, so we have now, and also here VL, when this is switched on, VL is VS, so I have VS is the same as L critical multiplied by 2 times I average is I in over K. All right, then divide that by KT. Okay, did you get that? All right, so now that means if you want to calculate L critical, so we can say L critical, just substitute the values there. Let's just make L critical the subject. So it will be VS K squared VS, this K squared T divided by 2I in, which is the same as saying VS is 40, K is 0.286 times 130 microseconds divided by 2 times I in, and our I in is 2. So let's get that. So I have 0.286 all squared, get 1.0633 times 10 to the power minus 4. Okay, that is Henry. 106.33 micro Henry. All right, that's a critical value there. Then the next question is to calculate the critical value of the capacitor. You do the same that we did here. Remember that IC, current flowing to the capacitor, IC is C delta V over delta T. So at critical value, remember that IC is minus IO, so I have minus IO equals C critical multiplied by here is now the output voltage, right? So critical will now be twice of V out, all right? 2 VO, and output voltage is a negative value. So 2 VO all over KT, like that. Okay, you got it? So you can easily calculate now the critical value, C critical, to be minus, we cast minus there, we have KT IO all over 2 VO. All right, which will give you 0.286 times our T is 130 minus 6 IO 5 divided by 2 times VO, and VO there, VO, we're not giving VO, you can just get VO from here, is 80 over 5. 16 volts, so you have that to be 16 volts. 5.81 microfarad. Now the last one is just use remember the equation for average value, RMS and RMS current of this average. This is average and this is average and RMS. Okay, average and RMS current of the switch and the diode. Okay, so what you do is I transistor, I just put the formula, you do it. I of the transistor, if you want to get I of the transistor average, you just multiply the duty cycle by I average. Okay? I transistor average is duty cycle by I average. So I average here. And we know what I average is, which is I in over K. So I of the transistor RMS is just the square root of K multiplied by I average. Okay. So for diode is I diode average is, so here you just put 1 minus K by I average. And I diode RMS is the square root of 1 minus K by I average. Okay, so you can use that to get the answers for the last one. All right, so thank you very much.